All right, let's talk about the future. A future that honestly is showing up a lot faster than any of us expected. Today we're taking a look inside DARPA's latest projects, where AI isn't just some abstract idea. No, it's actually flying fighter jets and sailing the open ocean completely on its own.
And I want you to let this sink in, because this isn't science fiction. Just this past April, a full-scale F-16 fighter jet, controlled entirely by an AI, went head-to-head in a dogfight with an expert human pilot. This one event is a massive leap forward, kind of redrawing the map of what we thought machines could do.
So the big question is, how on earth is this even happening? Well, it's not just one single invention. It's more like a three-part revolution, giving these machines a brand new kind of brain to think with, a totally radical new body to move with, and a design philosophy that just changes the whole game.
Okay, so first up, let's talk about the brain. If you're going to have an AI fly a jet in combat, you need an intelligence that can make split-second decisions in, well, one of the most chaotic and high-pressure situations imaginable.
This is where DARPA's Air Combat Evolution program, they call it ACE, comes in. Now, the goal here isn't to replace pilots. It's actually to create the ultimate co-pilot. The idea is the AI handles all the crazy high-speed dogfighting maneuvers, which frees up the human pilot to be the mission commander, focusing on the big-picture strategy.
And this is the plane that made it happen. It's called the X-62A Vista, which is basically a modified F-16 that's been turned into a flying supercomputer. And in these tests, the AI proved it could react at machine speeds, way faster than any human ever could, which, makes it an incredibly effective dogfighter.
But look, a genius AI brain is really only half the story. To truly unlock all that potential, you need an equally advanced body, and that's exactly what DARPA is working on by completely rethinking what an airplane even is.
And what we're seeing are two really radical ways to reinvent flight. On one hand, you've got the Crane program, which is designing planes with no moving parts on the wings at all, making them lighter, stealthier. And then on the other hand, you have the Sprint program. They want to create an aircraft that blends jet and rotor tech to get the best of both worlds. You get the crazy speed of a jet, but it can land anywhere just like a helicopter.
Let's just focus on Crane for a minute, because this idea is genuinely mind-bending. I want you to try and picture an aircraft with perfectly smooth wings. No flaps, no ailerons, no visible moving parts. But it can still roll, pitch, and turn just like a regular plane.
So how does it do it? Well, instead of using all these heavy mechanical flaps, it uses something called active flow control. It's basically jets of compressed air shot out from these tiny nozzles on the wing, and by controlling these air jets with incredible precision, it can shape the airflow around the wing and create the forces it needs to maneuver. It's like it's sculpting the air itself.
Now, this kind of revolutionary thinking isn't just stuck in the skies. DARPA is taking these same ideas of autonomy and resilience and applying them to the sea, developing a ship that's designed to operate for just incredible lengths of time all by itself.
1 year. That's the goal. A full 365 days at sea, navigating, doing its job, surviving the ocean without a single person ever stepping on board. Not for repairs, not for fuel, not for anything.
This is the huge ambition behind the NOMARS program. And to make it work, the designers had to throw out centuries of shipbuilding tradition, because all of that is built around the needs of a human crew. This is what they call a clean sheet design. They reimagine the ship from the ground up with one simple rule: no humans allowed.
And the key to making this all work is a concept they call graceful degradation. A good way to think about it is like a lizard that loses its tail to escape a predator. Yeah, it's damaged, but it keeps on going. The ship is designed the same way. It's built with the expectation that things will break over a year at sea, but the whole system is smart enough to adapt and just keep on functioning, even if it's at a lower capacity. So how do you actually build a ship that can survive on its own for a whole year? What's the secret that makes this level of resilience even possible?
Well, it all comes down to intelligent, redundant systems. There's an AI on board that manages everything. If an engine fails, the AI just reroutes power from another one. If a sensor breaks, a backup just kicks in automatically. See, the ship isn't designed to be invincible, it's designed to be incredibly resilient.
This quote from DARPA just nails the sheer ambition here. This isn't just a big remote-controlled boat. No, this is a truly autonomous vessel, designed for these super long endurance missions where it absolutely has to think for itself, and that's the real game changer. Having a presence anywhere in the world without putting a single human life at risk.
So, when you start putting all these pieces together, you've got the AI mind from ACE,
the revolutionary plane bodies from Crane and Sprint, and the self-sufficient design of NOMARS, you're not just looking at a few cool projects. You're really witnessing the dawn of a whole new era of autonomy.
So let's just recap real quick. We have the ACE program teaching AI how to dogfight. We have the Crane program building planes that fly without flaps. The Sprint program developing jets that don't need runways. And NOMARS building ships that can go a year with no crew. I mean, each one of these is a monumental achievement on its own.
But the real key takeaway here is that these are not just isolated gadgets. They're the fundamental building blocks for a future where humans and intelligent machines work together as partners. Each one plays to its strengths to do things that, before now, were pretty much impossible.
And all of this leads to a really critical question. As these autonomous systems get more and more powerful, more independent, we have to decide where we draw the line. What is the one task, the one final decision that we should never, ever hand over to a machine? That's something to think about.